Greetings. I was staying out pretty late yesterday. I was staying till about 3 o'clock. And I was watching this video by this guy. This video actually. And then all of a sudden I could see a flash outside. I could see it through the front door. I saw this flash. And first I didn't quite know what it was. I thought it was perhaps some kid playing around. So I went outside to check. And when I came outside I saw it was thundering all over, lightning all over. I stuck around a while to watch this because I love thunder and lightning. That's one of my favorite nature happenings. While I was watching this, it started raining, which was okay. I also love rain as well, so I really don't mind standing outside watching something while being soaked by rain. But it didn't last long for the rain to become so heavy that I couldn't stand outside anymore. I went inside, got my camera and stood beneath a shelter. As a matter of fact, I could actually show you this video right now. I was thinking while the thundering was going on and while I was filming this, the safest place to be during a thunderstorm is actually a car. And you know why? It's actually because the car is standing on wheels. And you know what wheels are made of, right? The exact same thing that's repelling electricity. Now, I'm going to go ahead and explain something about the electricity, how it moves and why it can't go to certain places if there's rubber in the way, for instance. Probably many of you already know the basics of why electricity can't go through air and such, so you're probably not interested in listening. If you already know this and don't want to listen, feel free to click at this, because that will make you skip the explanation. You don't want to listen once more if you already know it, right? Electricity is really only trying to get to ground, which makes us kind of seem pretty mean because we're torturing it. We're making it go all our other places than ground, through lamps and stuff. But all it really wants to is go to ground. That is why it's whenever the electricity has the option to do so, it will try to go through the ground. It will always try to reach the ground. That is why having ground in your electrical system at home is so important. Because if there is something wrong, if something goes wrong in the electrical system, the electricity will go to ground. If you had the option between going through one of your appliances and destroying it, or rather destroying you by going through you, or going through the ground, it would choose ground, no doubt about it. Electricity always chooses ground. That's its paradise. That's where electricity wishes to go. There is something called resistance, which is keeping the electricity from going different paths. And the resistance is actually the reason why electricity can't go through rubber or air, for instance. But resistance is only that strong. It depends on the material. There is resistance in everything, but not all resistance is as strong. Like, imagine this. If you wanted to get to the other side of the room, but there was a brick wall on this side and a paper wall on that side in the way, would you rather go through the brick wall or the paper wall? You'd obviously choose the paper wall, right? That's because it's the easiest way. That's the exact same thing with the electricity. It always chooses the way that is the easiest, the one with the little resistance as possible. You see, wires, they don't have a lot of resistance. They have some, but not a lot. Copper has less resistance than aluminum. Now, rubber has a lot of resistance. Of course, it doesn't have unlimited, and therefore it will take a whole lot amount of voltage to get through the rubber. Same with air. Air also has quite a bit of resistance. Now, to show you how much resistance air actually has, let me give you an example. There is this short between the wire and the point where the electricity wishes to go. And then there's a wire connected to this wire, which goes 100 meters down the road and then back up, and is connected to the point where the electricity wishes to go. The electricity actually chooses to go down the 100 meters down the road and back up, rather than jumping this short length to get to the point where it wishes. That proves that air is a whole lot of resistance. Wire is basically nothing. The less resistance, the easier it is for the electricity to go there. But for lightning, this is another story. For lightning, it's of very much voltage. There's a lot of voltage in lightning, and therefore it has enough power to go through this brick wall that is air. I was also thinking about something else while I was watching the thunder and lightning. I was thinking about this video I once saw. There was a demonstration of how good a high-speed camera is by filming a lightning that was going down. And it was really an interesting thing to see. It really revealed something I never knew before. Like that, the lightning starts from the sky, right? And it goes down, and it starts going down. While it's going down, you see all these other small lines going through, and they're spreading all over the place. They're going every kind of direction, trying to find the fastest way down to ground. So it's going down, and it's all of them trying to find one fast way. And they're going, and then all of a sudden you can see one small line hitting something, and then there's a bright flash of this whole line that found something becoming much stronger, and all the other small lines, they're disappearing. So, now, that was it from me. You have a great day now.